Hi, everybody. Welcome to the session on platform adoption engineering. I'm Sheila Shankar, and I'm an executive director at JP Morgan Asset Management. JP Morgan Asset Management is the world leader in investment management, and we have $2.5 trillion in assets under management. We're the top five in the Fortune 500 companies, and we have over 50,000 developers with $11 billion annual technology budget with three lines of businesses. My team is Morgan Advisor, and we build applications for financial professionals to analyze their portfolios, to compare funds, etc. And our team is a mix of back end and front end specialists. And our cloud technology that we use is primarily AWS, EKS, microservices, ECS, Lambda, etc. So wanted to share some of the applications that we build. So as you can see, they are heavy on the UI, heavy on data because you have to analyze portfolios. All of these applications are built and operated by us. We do not have any specific DevOps or SRE team. It's the developers that build and operate the system. So I wanted to take you on our cloud modernization journey. So our cloud modernization journey started way back in 2016. We started with Pivotal Cloud Foundry, which was platform as a service. We were on that platform for 5 years, and then we wanted a little bit more flexibility, more tools, etc. So we adopted the AWS and migrated all our services to the public cloud. Starting in 2021, it took us about 2 years to complete that journey, and now in 2023, we are in the maintenance mode. When we finished our cloud migration, we were blissfully happy, thinking that all the heavy work is done and we can now relax. But within a month of going live, we realized that there was a lot of heavy lifting that had to be done month over month. Let me introduce you to the cloud operating model and how does it work in JP Morgan. JP Morgan, since it has 50,000 developers, we have a really large global platform team that provides all the tooling necessary to build and operate a cloud platform. Namely, we have Terraform for infrastructure provisioning. For continuous integration, we use Jenkins. For our continuous delivery, we use Spinnaker. We have multiple tools for monitoring our applications, for detecting vulnerabilities, etc. So is that enough? Is tooling enough to build a cloud application? So tools alone are not enough. You also need skilled drivers. So for example, you do have Terraform, but you do need developers to be able to provision the right infrastructure. So they have to be um, at least aware of all the different tools available in AWS to be able to provision it. And also, you need developers to provision the right tools, so use the right tools for the right services. If something can be written using a serverless function, use Lambda. If it needs more um, functionality, then you would probably use an EKS service. Or if it's a simple container application, you could just use ECS. So you need developers to choose and pick the right tools. We do have Jenkins pipelines, but you need to be able to write good, efficient Jenkins build scripts so that your container images are optimized and are not bloated. You need your pipelines to be efficient. So that you can have your application build time as less as possible. The tools may also detect vulnerabilities, but you need developers to to fix the vulnerabilities. So tooling alone is not enough. You need skilled execution. In addition to that, we have in the public cloud world a lot of maintenance activities. So since we are using EKS, there's EKS cluster upgrades using blue green. That happens at least at a minimum twice a year. You also have database and Terraform stack upgrades. You also need to renew your certificates at least once a year. So this would be your load balancer certificates, your X509 certificates, etc. Then you may want to refactor your application because you constantly see that something or the other is not performing as well as you want it to be, or you are seeing that it is costing a lot, so you want to make some cost optimizations. So these are the types of activities that have to be done throughout the year. There is no respite, and it is not going to go away. That is just the reality. In addition to this, you also want to modernize the platform. So uh, today you're using manual pipelines. Tomorrow you might want to build abstractions. You might want to, for example, we just migrated from Jenkins to Spinnaker. So that required a lot of rewriting of all our deployment scripts. Tomorrow you might use GitOps, right? Using Argo CD. So there's always some amount of modernization that's always expected. So, what does this mean? This means that there is a lot of cognitive load to the entire development team who are building and operating this platform. So, I wanted to talk about the three different types of load. So, you have the intrinsic load, which is the minimum knowledge that you need to be able to um, write some code. The germane load, this is the good load, which you want developers to have. This is the load that you will have when you're building something new. So you're learning new skills. So, for example, you're adding machine learning capabilities to your microservice. You're learning something new, so you have that load for some time. The extraneous load is what you want to reduce, and this is the load that is, in addition to your application logic, in addition to something which you are learning, you also have to do this additional extraneous load, which is, for example, you want to spin up a new cluster, you want to deploy your application to um, a new EKS cluster, or you want to bring up your development environment, and that takes up a lot of work. That's all the extraneous load. And what happens is that the developer has, a limited working memory. So you overload too much, that causes a loss in productivity. So the main objective is how can you reduce cognitive load. So we read this book by Matthew Skelton and Manuel Pay, the Team Topologies book, and we decided to adopt that. And the book talks about having a platform team in addition to your stream-aligned teams to be able to increase the flow and to increase the efficiencies of the stream-aligned teams. So that's what we did. And we built our own platform user team. So out of a team of 30 people, we took about 6 people to work on the platform team. And a few skeptics may ask the question, why will this help in reducing cognitive load, right? And you already have a central platform team. So the difference is that previously in each of the individual teams we had platform developers playing the platform role, and they not only had to do the application logic, but they also had to um, actually make their write some sort of platform logic, platform code to make their application deployed on the public cloud. So instead of that, you now have a dedicated platform team that is just meant for making sure that they work side by side with the stream team, and they can also work by having different software as a service sort of functionality. So this helps in reducing the cognitive load, because now the platform user teams, um, they increase their germane load by, they have to only focus on the cloud platform, and the application streams, they are only focusing on building application logic. So it works for both the application teams as well as the platform teams by giving them just one area of focus. What are the key differences between the two platform teams? The central platform team is all about standardization, building blocks, having tooling for CI/CD and improving the developer experience, etc. Whereas the platform user team is all about building customizations as needed. They're using the tools which are provided by the central platform team to actually build applications. And they are building products. Um, they have a focus on FinOps, because your central platform team is not going to be able to monitor your cloud bills, right? So your team's cloud bills are um, our responsibility and not the central platform team. So our team is responsible for the security of our applications, the costs of our applications, how we operate it, and how we observe it, etc. So the platform user team's responsibilities are all about supporting the different applications for that particular team. So, what are some of the guiding principles that we have followed? First one is to build shared services. As I mentioned, we have a couple of tools that we build and operate, and all of them have similar requirements like authentication, authorization, sending out emails, making calls to external services, etc. We built, the platform team has a shared set of services which are reused by all the applications. Secondly, we have a very strong communication between the central platform team. So both the wins and frustrations are communicated, and we're also early adopters. Any new functionality that is offered, um, we're always ready to be the early adopters. Then our focus is on reducing the cloud costs and to make sure that we are operating as efficiently as possible. And for that, we do monitor our cloud bills, and make sure, for example, KubeCost shows you how many of your clusters are, how much memory and CPU is being really used. So optimize that, turn down environments if they're not being used, etc. We also want to build um, efficiencies and expertise by working, with the platform. And as you work more and more with the platform, your efficiency, your expertise increases, and the speed at which you do um, perform your duties also increases. So, for example, by having this platform team, when we migrated to Spinnaker, we were able to turn around um, all our pipelines by having a dedicated platform team, because they were only focused on that particular task. So, increasing efficiencies by focusing on one thing at a time. So, what are some of the key takeaways that I would want you to take away? Is You don't provide the platform alone. You also need to invest in developer training, because you want your developers to use the platform um, to all its abilities. You want them to use it efficiently and to use it well. So just having one platform team is not sufficient. You can have as many platform teams, and the only thing that determines that is the size of your application team as well as the complexity of your applications. Second is to be very mindful and to be aware of the time that it takes to run the platform. So it's important to have these objectives in while setting our OKRs. So we have clearly defined objectives that this is going to be um, the different initiatives that are going to be done by the platform team. And similar to that is to have a product mindset, because the platform team has a clearly defined backlog, which is and the items on that backlog come from the different application teams. So the platform team is not inventing tasks of their own; they are helping to increase the flow of the application teams. So treating the platform as a long-lived product, and also to um, have a clearly defined backlog, I think is very important. So I think that concludes my talk on platform adoption, and I hope you found it useful. And thank you for listening to this talk, and hope to see you again.